Chapter 6. Additional topic in trigonometry. On this chapter, I think you saw it in high school somewhere, it's talking about triangles. But to solve a triangle, we're going to use two formulas. One of them called law of sines, the other one law of cosines. All right, let's have a small review. If I have this triangle, this is 90 degrees. If I said this is KLM, what is this? Can I write Pythagorean theorem in here? You know Pythagorean theorem? That the one is, if you see it all the time like that, it said A, B, and C. C squared equal A squared plus B squared. Have you seen this before? You should have. But I don't here have A, B, C. What do I do? And this triangle's kind of flipped all around in space. Do you think I should still, I'm okay to use Pythagorean theorem here? Yes, it is okay because you can rotate triangle and the plane, it doesn't change anything. It's still right angle triangle, it does not change. But how do I use this? This is not a C, there is no C or A or B. Isn't the formula must have say in? No, you can have any name. You have to, the way you memorize it, you could look at it. The inclined edge first, K square equal the other one with the 90 degree angle between them, L square plus M square. That's it. So whatever the name, it doesn't matter. Now, remember that if I have an angle theta, let's call this is, let's draw another triangle. Like let's do this. Let's call this this is C and this is small c. This is A. This is A. This is B, and this is B. So basically, the small letters, they are the links of the edges. A, B, and C, they are the vertex and the angle. Here, C equal 90 degrees. Also, we call, if I'm looking for angle B, this is going to be opposite. This is adjacent. This is hypotenuse. Then sine of B equal opposite over hypotenuse. What are they? If we look at the other triangle, basically is B over C. Cosine B, it is adjacent ADG over hypotenuse. So basically adjacent to the B. So this is the B. Okay, look at it. This is the B. There's the B. Opposite is the B. This is the opposite. Adjacent, this is adjacent. C is the hypotenuse. So adjacent is A over C. What's that? Oh, okay. Then tangent, we know what is tangent. With this is before, but that's all right. Tangent of a B is equal opposite over adjacent, or sine B over cosine B. And that will be equal B over A. We could do the same thing for A, but we have to pay attention. What's the opposite to A? It will change. The adjacent will change. Well, this is right angle triangle. It's easy. Pythagorean theorem, sine and cosine and tangent, very simple. Well, let's look at a global triangle. If I have a triangle like that, no 90 degree, A, B, and C, this is the edge C, it's always facing. If this is angle C, this is the edge C. If this is angle A, this is the edge A. If angle B, edge B, they are facing each other. Can I use the previous equations? No, I cannot apply nothing from the previous page. The other one only correct if one angle is 90 degree. If only one angle 90 degree, then I can do everything in the previous page. So what do I do? How do I solve this problem? So that's what we're gonna introduce, law of sine. Law of sine is said A over sine of the angle A equal B over sine of big B equals C over, no, made the C too big. C is very small, that the H over sine of C. That's called law of sine. We have here, how many variables do we have? How many unknown? How many variables? 6, you're right. So we have 3 angles and 3 edges. If given 3 values, then calculate the other 3. So we need to know at least 3 of them to calculate the other 3. Why do we need to know 3? So if I know A, I know the angle A, and I know the angle B, then I can find the B value here. So basically, you cannot, I can use those together. We have 3 known, I find out the number 4. Or I can use this set together. So B and C, I cannot have 2 equal signs, it has to be only 1 equal sign. Or I can use, so I have 3 scenarios. I can use the first one and the last one together. So we have three scenarios. It depends what is given to me. Always I'm gonna find a way to have a 3 given value and 1 not known. So I have to kind of look at it. Which one have the 3 given? So I can find number 4. Then you do the combination, okay? You can flip this upside down. It's still correct. See here, this is the law of sine. And what they did here, they flipped it upside down. It's still correct. It will not, sometimes you may need to do that, but I never use the bottom one. I always use the top one, because I can find anything I want from the top one. On the same page. Example. We have a triangle. They give us the angle C equal 102. Angle B, 29. And they give us one edge, 28 feet. So we have what? 3 given values. What is unknown? The small c is unknown. The angle A is unknown. The edge A is unknown. So first thing you do here to solve this problem, we'll use law of sine. So let me write it down so we can remember it. A over sine of A equal B over sine of B. Oh, that's not big B, small b. Equals C over sine of C. Let's plug in for sake of argument. What do I know? Do I know A, small a? No. Do I know the angle A? No. So let's forget about this one. I know nothing about it. Correct? Do you see that? I don't know the angle A. I don't know the edge A. Forget about it for right now. Let's go over here. Next one. Do I know B? Yes. Do I know angle B? Yes. Do I know the edge C? No. But do I know the angle C? Yes. So that's the one has 3 givens, 1 unknown. I'm going to take this combination first. So what is B? 28 over sine of B. What is the sine of B? 29 equal C. I don't know. Sine of C, 102. See how it works. Like you examine what you have and you find, okay, what combination do you want? We find out we wanted B and C together. With A, I know nothing about it. Now, I need to isolate the C. Always remember, I told you this before, if I have A over B equals C over D, if I wanted the A value, I can move diagonally. I can move the B up here. That's fine. Then I can get A equal BC over D. I can move any, you can, like a game, you can move anyone up or down. If I said, I want to know the C value, I can move the D up. Then I can C equal AD over B. Or you can do cross product. AD equal BC. So unlike the war, that's what you learn in school. Do cross product, then divide both sides by something, and you get the answer. That's complicated to me. It's easier just think diagonally, move diagonally, just pick it up, put it there. You can take it from bottom, put it on the top, or take it from the top, put it in the bottom. Nothing is still correct. So for me, because I'm looking for the C, I'm gonna take the sign to the top here. Then the formula is gonna look like C equal 28 sine of 102 divided by sine of 29. That's it. You can do your calculator, you can find the answer. Don't need for cross product, just move the one you wanted to. Whatever your calculator do, I think you type the numbers in sine, divided number sign, multiply by 28, you should get the links. See. Let's see how much is it. Okay, there is one thing I forgot to mention. They did it first. Do you know those angles? If I say angle A plus angle B plus angle C, how much is that? How many? I think we talked about it before. What's the total number of angle in the triangle? A plus B plus C. That's 180 degrees. Okay. Now, because I know two of them, well, the third one is easy. What is the angle A equal to? Angle A equal 180 minus B minus C. You subtract the other two. So if you know two angles, the third one is easy. And that's what they did here in the book first. So they said A is equal 180 minus B minus C. So we got the angle A, 49. Well, the fact is, this angle now 49, I can go back and use the law of sine. Right now, A is given. Can I do this combination? A and B combination? Yes, we can. Because I know the B, I know the sine of B, I know the sine of A. The only thing is left is A. So that's what we're gonna do next to find. I don't know if the book did it first or not. Let's see what they did. Yeah, they find sine of, they find the edge A. But again, they are not showing you how they got it, but the thing is they're moving diagonally. Originally, it was sine of A here. I move it way to the top, it become B times sine of A over sine of B. If you want to write it down first like that, A over sine of A equal B over sine of B. Then you say, I'll move this one to the top. And that will give me this formula. A equal B sine of A over sine of B. It becomes 43.6. That's the A. All right, we already calculated the C ourselves. Let's see how much they got. So C is 56.49. Let me put them back because I'm gonna come back to this problem. C equal 56.5. A equal, forgot, 43 something, 43.6. Yeah, that's correct. All right. Now the problem completely solved. We find that A and C and the angle. Another example. In this example, they give us only one angle. So the first one, 2 angle and an edge. Now we have 2 edges and 1 angle. We have B, 12 inches, A, 22 inches, and A, 42 degree. At this point, I cannot use 180 minus. I need to find at least one additional angle first before I find the third one. Although the third angle is easy. The second one, it needs work. Okay, well, let's do plug in A sine of A. I mean, you can figure out which one you want to do from looking at it. I have A and the angle A. So basically, I'm going to have this one. Then I have C. I don't have angle C. Oh, I have B. I don't have angle B. Then that will work. B over sine of B. I'm not going to do the C because I don't know anything about the C at this point. If I plug my numbers, A is 22, sine of 42 equal. B, how much is B? 12 over sine of B. So in here, what to have unknown? The only thing is left to find sine of B. Again, how do I do it? The easiest way, do the diagonal move. I can move sine of B to the top and move the 22 to the bottom and move sine 42 to the top. It's not complicated. So I'm moving sine of B to the left or to the top of left equal. I'm moving the 22 to the bottom. The 12, I'm not touching it. I'll leave it alone. 12 is still in the place. So I move the 22 to the bottom. Then I move the sine 42 to the top. You want to do cross product? If you're confused, go ahead and do that. But honestly, it's very easy to do this. Move diagonally. Just keep moving until you get what you want. So we're looking to isolate sine of B. And that's what we got now, sine of B. If we calculate, now this is the angle. Sine of B is not the angle. We have to do sine inverse. B equals sine inverse whatever answer you get from here. Okay, the sine of inverse, that's an angle. This is just a sine. Okay, what they did here, they use a flipping case because it's easier. It's already sine B on top, but doesn't matter. You could move diagonally. Then they move the B to the top, which is okay. So you get sine of B is equal B sine of A. We plug in the numbers. Here we go. We already did this. Oh, B came up to be. I hate this because why don't you say sine of inverse of this number? B is sine of inverse of that number. Then you get 21 degree, 0.4. So if you know, how do you find the third angle? The C. C equal 180 minus 42 minus 21.41. Because now I know 2 angles, the third one is easy. If we did this calculation, C is equal 116. So this is 116, B 21.4. What is missing right now? What is missing is the C, small c. I can use any combination, including the C, because I know this angle, 116 points, I don't know what was the fraction, 6. Okay. I can say A over sine of A equals C over sine of C. Okay, I use this combination. What is A? A 22 over sine 42. Equal, what is C? I don't know. Divided by sine of 116.6. Now you move the sine to the top, you get C equal 22 sine 116.6 over sine 42. Okay. We know how long is the C. Let's check the answer. $49.4. That's the value of the C. And make sure of something. Make sure your answer makes sense. If this age 22 and this edge is 12 and this angle 116, that is going to be the largest edge, because when the angle is big, the edge is facing is also big. What would happen if you got the answer equal 5? If I told you C equal 5, do you believe it? Does it make sense? Your calculator gives you that number. What do? You're going to think, uh-oh, well, I have a 12 and 22, and this angle really big. I must have a number bigger than those two numbers. So try to make sense of your answers. Let's say you got, instead of 29, you got 294. I wouldn't believe that. That's too big, huge. Kind of like, you have to question yourself. 12, 22, I need to get something in the close neighborhood. It could be, 30, 40, 50, okay, but 300, yeah, that could be too much. It is possible, but it's gonna be, normally you're not gonna see it in academic problems, okay? Area of the triangle. Area of the triangle. If I have a triangle like that, A and B and C, and this is C, this is A, and this is B. I'm going to draw a vertical line from C into the base C, 90 degree. We're gonna call this one HC. That's the height from C to base C. HC is height from C, the big angle from C to base C. Now the area equal half base or half height base, whatever. I don't know if they wrote it. Half height base multiplied by base. So I don't like to use, for this situation, for this case, area equal half HC multiplied by C. Okay, this is half base. I don't like symbols, I like meaning. Half base height or half height base. That's the area. Well, I know the value from the previous example. I know the C. How do I calculate the HC? That's a big question. We're going to go back to the review at the beginning of this class about, do you see this? Isn't that right angle triangle? Right? What is the sine of B equal from this angle, from this triangle? What is the sine of B equal to? It was opposite over hypotenuse, right? What's the opposite? What's the opposite of B? HC. So HC. What is the hypotenuse? The inclined edge, the A. Now here, cross product, move this to the top, then HC equal A sine of B. So basically, we always try to think of sine to find the H. So that's the way you find the H, by using the sine, using right angle triangle. Okay, well, I have 3 vertex, correct? I can find the 3 height. If I wanted the height from A to A, well, the thing is, if you look at it here, I cannot go inside because I want to make 90 degrees with the A. I have to extend the A. You extend the A, then make the 90 degree. HA. I'm going to help you now. How do I calculate HA? Find out, we have also right angle triangle. Look at this one here. You have a big right angle triangle. What is the sine of B again? It happened to be sine of B, but not always. Sine of B equal HA over the hypotenuse. What is the hypotenuse, Maria, in this one? So look at the green triangle. This is 90 degree. Then I'm connecting this way. Well, the hypotenuse is always the inclined edge in the triangle. This is the hypotenuse. Where is the hypotenuse here? You have to find, it's always facing the 90 degree. Let's do that. Whatever facing 90 degree is the hypotenuse. Exactly, it's just C. Whatever facing 90 degree is the hypotenuse. So maybe that's one way to remember it. Then HA is equal C sine of B. There's another one. If I extend AC, now the base here is still A. It does not change. Then I have to draw a 90-degree angle. It has to be 90 degree. So this is HB. What triangle you should use? How do I calculate HB? What angle I have to use this time? Tara, what angle I should use? I have this is 90 degree. Which angle? I have to say sine of, like here, I said sine of B. What angle I have to use this time? Sine of what? What facing HB? That's the easiest way. What angle is facing HB? A. Because this is the right angle triangle. That's the big one. So this is the A. That's equal HB over what is hypotenuse here. Still C. You're right. Because this is the inclined edge. So then HB is equal C sine of A. So no matter what, we can calculate the value of the height. So we have three cases. Let's try to do an example. Let's share. What's the area of this triangle using what we learned so far? If I used this height, HC, like what we did a minute ago. So what is HC equal? We're going to say the sine, the angle facing HC is B. Sine of 21.4 equal HC over hypotenuse. The angle 90 degree is facing A. So that 22. Then HC is equal 22 sine of 21.4. Then we can find the area, half base height. How much is that? Oh, I don't know if you see, this is the sine of 21. Sine 21.4 multiplied by 22. How much? 21.7. Let's see. Seem high a little bit. Oh, you need to change your default to degree. There should be a button somewhere in your calculator because you are in radian. Oh, okay, 8 point what? Why did I know your answer is wrong? It's too high. Because I looked at, I have it 12 inches. It must be the height a little bit shorter than 10, than 12. Could be 9, could be 8. So I guessed it. You know, you can guess the answer by just looking at the drawing. And immediately I know you are using radian, not degree. I don't know, it depends on each calculator. I saw somewhere it said have an arrow that it said rad to degree or degree to rad. Each calculator is different. Somewhere it should show you really have to look at your manual. We have many here. And how about total setup? Do we see anything about the unit angle? Yeah, you need to find your little calculator. Because if they show you like an arrow, it said degree to radian or radian to degree. Exactly, you have the number. How to prove this change that between radian and degree. Okay. Now, we got this number 8. Now, what's the area? Equal half 8.027 multiply. What is the base value? The base is always connected with the height. That's the height, that's the base. C, that's 29.4. That's it, we got the area. The other one I showed you, you could do it the same way. Also, there is another one. Well, before we do that, let's go back here, page up. Okay. One way you can convert all your angle to radian before you use it. That's the hard way. Before you say sine of 21, say sine in your 21 multiplied by pi divided by 180. Always multiply by pi, divide by 180, it become, no, the other way around. Yeah, yes, that's correct. You multiply, if you know you have 20 degree, yeah, you multiply by pi, yeah, multiply by pi, divide by 180. It become a radian. Then you take the sign of that number. Okay, let's do the area of this triangle using height from A to A. So that means I have to extend these things, and this is my HA. How do I calculate the value of HA? You have to find the right angle triangle. First thing, what's the angle facing HA? B. So sine of B equal HA over what is the hypotenuse? What the line that's facing 90 degree? See, that's dividing 56.45. I forgot what is it. Well, let's assume 4, doesn't matter. Okay, now I can find HA by multiplying those together. So sine of B, so HA is equal 56.5, I think that's a half, multiplied by sine of 29. Okay, so that's if we have scenario like this, then have base height. You don't need to know how long is this. Look at me here. You don't need to know how long is this piece. You don't need to know. Base is all is gonna be A, regular. So area here, area equal half HA dot A. That's it. Is that the base? No. Yes, that's the base, A. Because that's the 90 degree between those two lines. That's the height, that's the base. So, but you don't need to worry about how long is this, doesn't matter. A is A. There's another formula to calculate the area. It said area equal half side 1 multiplied by side 2 multiplied by side angle between. You can pick up any two sides, multiply them, and multiply them by the sine angle between them. That's slightly easier than the other one. Like in this example, let's pick up any two edges. Well, I think they have an example. Let's do the example they have. Okay, this is an example. They're asking you to find the area of this triangle. What they gave you? Only one angle and two edges. But it happened, this angle between those two, I said side 1, side 2. That's the angle between. So the area equal half. Side 1 is 52. Multiply by side 2 is 90. Multiply by sine 102. That's it. That's the area. Okay, let's go back to this triangle here. Pick up any two edges. Here, pick up any two edges. Any two. You have only 3, so pick up 2. A and B. So half A, 22, multiplied by B is 12. What's the angle between them? Sine of angle between them. What's the angle between them? 116.6. All right. Maria, pick up another one. Another edges. A and C. So half 22 multiplied by 29.4. What's the angle between them? Sine of 21.4. That's it. So it's pretty easy. You pick up any edges, any two, you multiply them, divide by 2, then multiply. Don't forget sine of the angle between them. Well, let's practice the first one. The second one is from the second section. You have two edges and one angle. I need to draw with a scale. Let me show you how to draw with a scale first. Okay. If I have A equal 5, B equal 11, C equal 20, okay? This is if all edges given, okay? I'll give you one with an angle. So what I do, I draw the largest one first. C equal 20, that's what I do. So the big C is gonna be somewhere in the top. I don't know where yet. Correct? I don't know where yet. Okay, I can say, I'm gonna call this is A and this is B. Then this is going to be here, B on this side equal 11, and A on this side equal 5. Which one is bigger, B or A? B. That means I need to, if I need to put a point for the C, should I go to the left or go to the right? So I want to place a point such way B is bigger than A. So if I eyeball it, this is 11 almost 2 times. Maybe here, how about this location? Do you think C here is good? Because if I connect, yeah, this is about 5. If I connect, this is about 11. It doesn't have to be accurate, relatively need to be correct. That's what I'm saying, draw it with relative scale. You know, some students, they draw it this way. You tell me this is 11, this is 5, and this 20. I mean, you cannot solve the problem correctly if you draw it ugly like this. So we have to do this in prospect correctly. Now let's look at, let's say I have A as 5, B as 11, and let's get the angle A equal 40 degrees. How do I draw this? That's kind of a little bit harder. Well, let's start with the B. Because I have the A, maybe I should start with the A. So this is the A equal 5. Well, the angle A is between B and C. So it doesn't work that way. It's between B and C. So let me go back and start with B. B equal 11. And the point B is going to be in here. If I say this is A, okay, now it's work better, and this is C. How much is the angle A? 40 degrees. How do you imagine how big is 40? One way to do it, if I draw an angle 90 degrees, half of it, how much? 45, right? 45. If I take 1/3, that's 30 degrees, right? 2/3, that's 60 degrees. So if this is 40, so it's kind of like, it's almost 45. 45, almost 45. All right, so basically if I said, well, this is 90 and this 45. So maybe this is 40. So I say this is 40. Now, how much is A? A, we said equal what? 5. Well, if this is 11 and I need to get 5, that's gonna, the higher I go, it's gonna get big. So I need to go a little bit low. Maybe my numbers doesn't make sense. Let's use A equal 7, because it seems like I cannot make it fit. But sometimes it doesn't work. You have to pick up correct numbers. So maybe that could be a 7. That's okay. So I got it, or nicely drawn. Even if you draw it first time wrong, then try to correct it in the next try, because you will know you did it wrong first time. Try to let's go back to the example. You have this example here. A is equal 15, edge C equal 24, angle C is 115. Find A and B and area of a triangle. I need to edit this one. Area of triangle using 2 formulas, 2 different formulas. It's like what we did. We have half base height and we have half side angle with sine angle between. Sketch with a scale.